Hello. In part 4 of lecture 17, we are going to have a look at examples related to filters that we have learned in the previous slides of lecture 17. Okay, so far, just to recall back, we have learned about two types of filters, which are the low pass filter and high pass filter. We have learned about the circuits which include the RL and the RC circuits, which actually we only considered a case of first order type of low pass filters and high pass filters. Okay, so for these examples, we are given a transfer function of a network which is given by Hs equals to 2 over S plus 5. So we are requested to sketch for the magnitude and the phase both plot for the above transfer functions. And after that, we have to determine the filter type. Okay, so without sketch the magnitude and the phase plot for this transfer function, okay, and we can actually deduce that this type of transfer function is related to a low pass filter. That's what we have learned in the previous slides, yeah, of lecture 17. But for the sake of proving, okay, so we're going to sketch the magnitude and the phase plot for these transfer functions, yeah. And afterwards, we're going to determine what should be the filter type, yeah. So we just need to prove that this filter is actually a low pass filter, yeah. Okay, so let's have a look at the solution for this examples. So we are given the Hs, which is given by 2 over S plus 5. So we have to write the Hs in the form that we, in the actual form that shall be used in calculating or in sketching the Bode diagram. Okay, so we need to take out the value of 5 from this denominator, and for that we are going to have Hs as 0.4 divided by 1 plus S over 5. Yeah, so this should be the form that should be used in calculating or in sketching the Bode diagram, in which we can say that we are having two individual plots. The first one should be a constant of 0.4, and another one should be a pole at 5. Yeah. Okay, so we know that for 20 log 0.4, so we need to write this Hs in terms of the dB scale. So we are going to have a 20 log 0.4, which equivalent to be equals to negative 8 dB. Okay, so for this, it's going to have a constant of negative 8 dB. All right, and for a real pole at 5, okay, we are supposed to get 0 dB amplitude or magnitude up to the value of 5. And after 5, we are supposed to have a slope of a negative 20 dB per decade. Okay, so the plot of a constant and a plot for the real pole needs to be added. So when we add these two plots, or yeah, these two plots, we are supposed to get a case whereby this constant amplitude shall be scaled down to negative 8, since we have a constant of negative 8 dB there. So the combination of these two, we are supposed to get a new constant which should be located at negative 8 dB. And at 5, yeah, we are supposed to get a slope of negative 20 dB per decade. So that should be the amplitude plot for these transfer functions. Okay, and for the phase plot, we just need to consider the phase plot for a real pole. Real pole, we don't have to consider the plot for the constant, because the plot for the constant will be 0 degrees all the time. Yeah. So for the real pole plots, that's what we have learned in lecture 16. Yeah. We are supposed to get at 5 radian per second, the phase should be negative 45. For 1 decade lower, which is at 0.5, the phase will be 0 degrees. And for 1 decade higher, which is at 50 radian per second, the phase will be at negative 90 degrees. So we can connect these 3 points here, 0 degrees, negative 45 degrees, and negative 90 degrees. So we are supposed to get the phase plot to be look like this, which is given by this red line. Yeah. Okay, so that should be the amplitude plot, and this should be the phase plot for this transfer function. And evidently, it shows that from this magnitude plot, we can see that this is a low pass type of filters. Yeah. Okay, hopefully it's clear about this example. So let's have a look at the second example. Okay, so we are given a circuit in this case where we have a circuit of RC network. Yeah, and RC network supposedly it should be a filter type. And in this particular example, you have the information. We have the input voltage of V in T. The voltage across resistor R is VRT, and the voltage across the capacitor is VCT. So we are requested to evaluate the transfer function of the network. Yeah, the first one is if the HCS is the VCS over the V in S. Yeah, the voltage across capacitor over the input voltage, and HRS is the voltage across the resistor over the input voltage. So we have to write the equation or the transfer functions for two different cases. Yeah. So, all right. So let's have a look at a solution for these examples. So we have these circuits just now, yeah. So we have the VCS. So what you have to do, you have the VRS. So what you have to do is that we have to transform this circuit into the S domain. Okay. So we are supposed to get V in S as the input voltage. We have resistor of R there, which is there's no changes on the resistance of R, and there should be a changes on the capacitance where in the S domain it should be equals to 1 over SC. Yeah. Okay. So now the voltage the voltage across the resistor is known to be VRS in S domain, and the voltage across the capacitance is a VCS, yeah, in S domain. Right, so let's calculate obtain the transfer function for both cases. Yeah, first we go for the transfer function of the HCS, which is the output voltage across the capacitor over the output voltage over the input voltage. Okay, so we are going to use a voltage division. Yeah, voltage division. So by using a voltage division, we are supposed to get 1 over SC over R plus 1 over SC. And for this, we are supposed to get 1 over 1 plus SCR. So looking at these equations here, we can deduce that this should be related to a low pass filter, right? Because we only have a real pole and a constant there. So since we have a real pole and a constant, this should be a low pass filter type, yeah? Whereas if we proceed with the another transfer function, the output voltage across resistor over the input voltage, we are supposed to get R over R plus 1 over SC. You can prove this using the voltage division still. So we're going to get SCR over 1 plus SCR. So from this equation, we are having the zeros at origin. Yeah, we have zeros at origin. We are supposed to get a constant, and there should be a real pole. So from this transfer function and from what we have learned in previous lectures, previous slides of lecture 17, we know that this should be related to high pass filter. Yeah. Okay. So yeah. So next part of this is with the Adawood diagram, determine the filter type by HC and HRS as well as the cutoff frequency if R is 4.7K and C is 47 and 5. Okay, so this will be just substituting the value of C and R, yeah? And again, need to sketch the both diagram, both the magnitude and the phase plot, and prove that one of these transfer function is for the low pass filter, another one is for high pass filter. So I shall leave this for you to solve this because the examples for the both diagram have been shown. Yeah, has been shown in the previous example. So I believe that if we have these two transfer functions and given the value of R and C, you must be able to sketch the method, the both diagram for both transfer functions, and from here you can determine the filter type. Yeah. Okay. I think that's all for this example. So, okay, for lecture 18, these are the topics that will be covered. The band pass filter, the band reject filters, and high order filters. But as I mentioned in the lecture 17, somewhere in lecture 17, these topics will not be taught in class. Okay. Uh, so we just put these topics in your syllabus just for you to understand that these filters, basically the band pass and band reject, both of them are related. The minimum order that it can be is a second order type. Okay, and since our syllabus is only related to the first order type, so we're not going to cover this type of filters in detail. Yeah, but we provide you the notes. Yeah, and we are hoping that you can read these filters on your own. Yeah. Okay, so with that, just to conclude that we are not going to cover lecture 18, and this will be the end of chapter 5. Yeah. Okay, so next lecture, like number 19, we are going to proceed with a new chapter, chapter 6, which is on the filter design technique. Yeah. Okay, I think I'm going to stop here. Thank you very much. Hope to see you again in lecture 19. Bye-bye.